Welcome back from spring break as we continue with the second half of CIS 77. After this lecture, I'll explain to you how the labs will work for the rest of this course. The lectures are now really focused on a particular subject, but the work ahead I'll lay out to you in just a bit. So let's roll into Module 9, which is all about mobile forensics, and really a brief talk into how that works, into what that's like, kind of fill you in on this realm. So a cellular network is exactly that. It's a group of cells or geographic area within a network. A cell site is a tower that you've seen everywhere. That's in the cell. The mobile switching network or mobile switching center switches data packets from one network path to another on a cell network. If the user is managed by another carrier, the call will be routed from the MSC to the public switch telephone network, an aggregate of all circuit switch telephone global networks. Cell towers like these are usually about 200 feet high, with the transmitting panel in the middle and the others receiving panels. These towers are all controlled by base station controllers, or BSC, who handles the frequencies and handoffs as mobile equipment move from one cell to the next. A soft handoff is when a cell phone communication is conditionally handed off, or in other words, the signal strength on the new BTS will be adjudicated from one base to another, and the mobile equipment is simultaneously connected and communicating with multiple base station controllers. The hard handoff means the communication is only handled by one base transceiver station at a time. Now, without going too deep into the world of cellular technology, understanding how the cell network is structured is good to understand the type of evidence that you can retrieve from a carrier's network without accessing the suspect's device. Law enforcement can request cell site records from any carrier, specifying the format they wish the evidence to be in. Law enforcement can contact the carrier and explain the user information they seek, as well as that the customer not be notified. They can request the suspect's record be preserved for 90 days, pending their acquisition of a search warrant. And court orders can extend this for an additional 90 days. Law enforcement can obtain subscriber information, like the name, address, SSN, call detail records that are used for like billing, such as the phone numbers called, the duration, date, times, the cell sites used, and any PIN unblocking key codes to bypass any SIM protection, used to corroborate evidence from the carrier and the user's device. A mobile station is anything that has a SIM card. So that could be a phone, that could be a tablet, that could be a laptop, that could be a hotspot. Those are all mobile stations. The International Mobile Equipment Identity, IMEI number, uniquely identifies that handset. The initial 6 to 8 numbers are the type allocation code that identifies the type of wireless device. There is a site in the lecture notes that you can see details about specific devices. There are also other numbers within, like the Universal Integrated Circuit Card for smart card identification. For GSM networks, they'll use the SIM card for UTMS, which we don't necessarily see around here, is the Universal SIM. The Mobile Equipment Identifier, or MEID, is an internationally unique number for CDMA devices. CDMA devices have a subsidy lock confining the subscriber to certain cell networks so that it can be activated, so that it can be sold for free or at a subsidized price. This means that a phone's file system cannot be acquired with an active subsidy. For example, an iPhone could be $99, but you are locked to a particular carrier in contract, whereas a phone paid at full price can be unlocked. This is good to know because the phone may have been used internationally with a SIM card purchase abroad. You typically will not find this kind of lock in Europe. All phones in the US have an FCC ID indicating that the device is authorized to operate on radio frequencies within the FCC's control. This also means that you can get more information about it from another site that I've linked in the lecture notes. CDMA is only 3G. 4G LTE is a new system that is not GSM or CIS. I actually am not sure. SIM cards, or actually IMSI, is another internationally unique number on a SIM. The mobile country code, MCC, is the first 3 digits, with the preceding 2 to 3 as the mobile network code. A mobile subscriber identity number is created by the carrier and identifies the user on the network. The mobile subscriber ISDN is the phone number of the subscriber. SIM cards also have an integrated circuit card ID, a 19 to 20 serial number located on the card, helping to identify the origins of a SIM card. There is a whole process on authenticating a subscriber on a network, like the home location register, the visitor location register, the equipment identity register, and authentication center, all used to verify a user on a mobile network. There are 2 main cellular network types. There are the mobile network operators who own and operate their networks, like these guys. The mobile virtual network operators do not own their own network, but operate on the network of one of these guys. For example, these 3. Cell communication has evolved from the days of 2G through 5G. Different types have been used with different folks. Like, for example, a CDMA is a Verizon and Sprint thing. GSM is used internationally. Again, I don't know off the top of my head if a CDMA is restricted to only 3G, but I do know that a GSM is more international. Interestingly enough, SIM cards do have an interface to communicate, and it is that little connection there. Within a SIM card, there's EEPROM, where the hierarchical file system exists. The operating system, user authentication, and decryption algorithms are in ROM. 3 primary areas of the SIM card are the master file, the dedicated files, and elementary files. The elementary files are where subscriber information is stored. You have the abbreviated dialing number, any contact names and numbers stored, the forbidden public land mobile network, cell networks, the device attempted to connect but was not authorized to, useful to know where a suspect was located, the LND, or the last number dialed, as stated. LOCI has the area where the last Ugh. The area where the phone was powered down. It'll store a temporary location there. So you know, if you look into that file, you'll see where the phone was last when it turned off. And SMS is the list of text messages. Since SIMs are pin protected, you typically have 3 attempts to unlock it before it's locked, and then you'll need to get the unlock code from the carrier. Speaking of SIMs or SMS, you can see whether a message was read, deleted, unread, sent based on the status flags. MMS messages can be carved using forensics tools, but with SMS, this is the status flag that you would see on text messages. Now, taking a quick detour into Android partitions, some of the most common partitions you will find on an Android phone are the boot, which contains the boot code for the device, includes the kernel and RAM. It has the system partition with the Android framework, the recovery, the cache to store temporary data, miscellaneous that has for recovery, the user data where the apps are installed, metadata, the Dalvik cache, which has the executable files, applications, any APKs, data, which is subdirectory for each application with SQLite databases. You have miscellaneous and system. Gaining access to evidence on a suspect's system is challenging, especially with mobile. Since forensics is a science, you have to be able, whatever you do has to be repeatable. With mobile, circumventing encryption often means destroying the device beyond repair to access the data. Mobile device forensics requires the entire system and may not be able to separate the volume during the examination. Write blockers are typically not an option, and creating 2 copies may not yield the same hash. Outside of logical and physical ways to extract evidence from Android, there's also JTAG and chip off. JTAG is the Joint Test Action Group, an IEEE standard for testing, maintenance, and support of assembled circuit boards that is an increasingly important way to bypass security and encryption on a phone. This picture is of a RIF box used to acquire data from the circuit board on a cell phone. A full dump of memory can be obtained by extracting the contents of eMMC. The connectors are soldered onto the JTAG points on the board, and voltage is applied on the board using the cell battery. This comes into play after an attempt with tools like Cellular, who tried to read the contents of the phone without opening it and soldering stuff. If that fails, then JTAG would be next. And if JTAG fails, then the last resort is the most expensive, which is chip off, requiring specialized skill. It's not always successful, but chips are removed from the board and added to an adapter to be read. As with any tool, you need to be able to verify that your tool works and works consistently. When it comes to getting mobile devices, it's a little trickier. So you still have to secure the evidence or secure the scene, document it, collect any evidence and package it. Proper containment for these types of devices means removing the device from the network with a Faraday box like these that are shown below or shown here. Remember that the issue with mobile devices is they require frequent charging because the device will boost the signal in an attempt to connect to the cellular network, along with other apps trying to communicate as well. Once the phone shuts down, there is the risk of encountering a user's PIN or password to unlock. The use of signal jammers is illegal, even for law enforcement, because the FCC has stated, should an emergency arise, a person in distress may not be able to contact emergency services. Cell phone carriers should be contacted to ensure that the phone is removed from the network. It is possible for a criminal to report a lost cell phone and have it erased before law enforcement can seize it. So I mentioned Celebrite. Another tool similar like it is Gray Key, used to bypass encryption to get into the device, read the contents. Interestingly, a difference between computer and mobile forensics is file fragments. When an SMS message is deleted on a phone, you can generally be certain it is removed and no fragments exist. A physical extraction could result in some deleted files. When all else fails, but you can still have access to the device itself, law enforcement will use something like this: a manual examination of a phone, taking pictures as they thumb through the phone's content. That can still count as evidence. The legal considerations of all this, recalling from Module 7 before we took the break, a warrant must be obtained for a cell phone with exceptions, including consent, incident to arrest, and exigent circumstances. Warrants should describe the cell phone and include details like the make, the model, the manufacturer, the phone number, and location of the device, address and specific location. If available, the IMEI or MEID should be included along with the type of evidence that is being acquired, like SMS, MMS, contacts, etc. Any questions on this topic? Okay.